to minus 80 degrees. In just a few minutes, it will drop the temperature down there. This freezer right here is set up with communications. So a little reflection there. As you can see, there's a trend line where the set point is at minus 80 degrees and it is now at minus 71 and it's traveling down. As you can see right there by the cursor, that's the trend line heading down towards minus 80 degrees. This is really handy for purposes of data logging if you want to keep track of what your freezer has done over time. Basically though, you're not going to see any change because once that hits minus 80, it's just going to stay there at minus 80. And that's the cool thing about the Solution 1. It runs on liquid nitrogen. So as you see here, here's a small dewar of liquid nitrogen. That's a 10-liter dewar. This 10-liter dewar runs Solution 1 for about 7 or 8 hours. It runs on about 1 liter per hour. It would run more, but there's a cool down in the very beginning. So that little dewar lasts about 7 to 8 hours on Solution 1. You look inside here, you see some really cool stuff happening. If you look up there on the top, you can see it's so cold down inside this chamber that it is freezing the vapor that's inside the air that touches the top of this chamber. The cool thing about my technology is it continues to cool even when the door is open. So if you remember, we just set it at minus 80 degrees. Now it's at minus 77, but the door's open. So no matter what you do, if you open the door or if you close the door, of course it's a lot more efficient with the door closed because of the added insulation. But if you open the door or you close the door, it remains same temperature. We don't have heat swings like you see in your common ultra-low temperature freezers.